Talking about lines today, right? Equations of lines, slopes of lines, intersecting, parallel, perpendicular, all that kind of stuff. So, slope of a line, okay? We think about that as rise over run, right? The change in the y values over the change in the x values. That's how we define slope. And given 2 points, usually we say that's x1, y1, x2, y2. What's the formula for slope? Who remembers the formula for slope? Yeah. y2 minus y1 over x2 minus x1. Right? That's our formula for slope. Okay, but in terms of real world problems, it's better to think of slope as a rate of change. Okay, how quickly something is changing. Right? Now there are kind of 4 types of slopes. Right? We could say that a slope is rising or positive. What would that look like on a graph? Yeah, a line going up from left to right. Right? Okay, we always think about these as reading a graph from left to right. So looking at this line is going up from left to right. Okay, we can have a falling or a negative slope. So what does that look like? And just something going down. We can have a 0 slope. What does that one look like? People always get the 0 and the undefined mixed up. So is 0 the vertical or the horizontal one? 0 slope is horizontal. Okay, and then the last one, the undefined slope. Undefined slope is a vertical line. Right? So the greater the absolute value of the slope, right? So whether it's positive or negative, we can still say that the steepness of the line changes, or the steeper the line is. Right? The greater the absolute value of the slope, the steeper the line is going to be. So let's jump into some examples here. Okay, first, just finding the slope between a couple of points. Okay, and then stating whether the line is rising, falling, horizontal, or vertical. I guess I should have put in parentheses that 0 slope means horizontal and undefined slope means vertical. Okay, so we're using our formula here, right? M equals y2 minus y1 over x2 minus x1. And it does not matter which coordinate point I choose to make my x1, y1. I can make either of them x1, y1. Oops, x2, y2. There we go. So go ahead and try both of these, right? Plug your values into the slope formula and calculate the slope for both of these. Remember, whenever you're plugging in a negative value, make sure you put it in parentheses so that you keep all of your negative signs straight. positive slope. It's rising. Right? Whenever we end up with a 0 in the numerator, that means it's horizontal. Okay, for the second one, okay, that would be a horizontal line. Hopefully we got positive 1 for the first slope. Okay, that means it's rising. Now, we can make a little note here, I guess. 0 in the numerator of a slope means m equals 0, or we have a horizontal line. Right? If we get a 0 in the denominator of a slope, that means our slope is undefined, or it's a vertical line. Okay. 0 in the numerator is a 0 slope. It's horizontal. 0 in the denominator means it is a vertical slope. All right. Questions about slope? All right, then let's move on to equations of lines. What is the point slope form of a line? Anybody remember the point slope form of a line? That's slope intercepts. And slope intercept form of a line is y equals mx plus b, right? Where m is the slope and b is the y-intercept. What about point slope? What's the point slope form of a line? Something weird. I think slope intercept is the one you use most often, right? Point slope is y minus y1 equals m times x minus x1. Okay? Where m is still the slope, but the coordinate point x1, y1 is any point on the line. Okay? So this equation is actually pretty useful, okay, when we're writing equations of lines. The one that we use least often is probably the general form. Does anybody know the general form of a line? ax plus by. We can either say plus c equals 0 or equals c. Either of those are considered a general form of a line. Okay, so this one is usually, they give you that as the beginning of a problem, and then you have to put it into slope intercept or point slope to actually do anything with it. All right, that's usually what happens. Okay. So this is useful for finding intercepts. Okay. If I set x equal to 0, I can easily find the y-intercept, or vice versa. If I set y equal to 0, I can easily find the x-intercept from this form. All right. Questions? All right. Flip over, and let's take a look at writing equations of lines. Okay, so my ultimate goal is to get all of these into slope-intercept form, right? But point-slope form may be useful as an intermediate step sometimes. So the first one says, write the equation of a line that goes through the point -1, 0 and has a slope of 2/5. So right off the bat, I know my m, right? And I know some point, -1, 0. Well, if I have some negative or some random point on the graph, it's probably going to be best to start with point slope. Now, you don't have to use point slope. You could use y equals mx plus b here and plug these values in for y and x and solve for b. But I think it's a little bit easier if we get in the habit of using point slope form. Right? So I'm going to plug 2/5 in for my m, -1 in for my x1, and 0 in for my y1. So what we end up with is y equals 2/5 times x minus -1. Again, remember, whenever we have a negative value, putting it in parentheses when we're substituting it in. Right? I guess for this step, I'll go ahead and write the y minus 0. Right? Then distribute this 2/5, so we get 2/5 x. This is really like plus 1, right? So 2/5 times +1 would be, I think that's 2. Would be 2/5. Right? Y equals 2/5 x plus 2/5. Feel okay with that one? All right. So in the second one, we're given 2 coordinate points. I need the slope. How am I going to find the slope? Given 2 coordinate points, how am I going to find the slope? Yeah, use that formula. Go ahead and do that. Find me the slope between those 2 points. You get 2. Now what? I have the slope. So now I still need to write the equation of the line. What should my next approach be? There's a couple of different ways we could go about this. So yeah, we could use point slope. Jaden, is that what you're going to say? Yeah, so we could choose either of these coordinate points and plug them into my point slope form of a line. So y minus y1 equals m times x minus x1. Which point do we want to use? 1, 3? Okay. So we'll have y minus 3 equals 2 times x minus 1. So distribute this 2. We get y minus 3 equals 2x minus 2. Add the 3 over. We get y equals 2x plus 1. Okay. Absolutely works. Let me show you a way that we could have done that in one step. That's a y-intercept. Whenever we have a y-coordinate of 0, that's a y-intercept, right? So this tells me my b value right off the bat. There's no harm if you don't recognize that, right? I mean, we still got the correct answer. right? But if you recognize something like that, you can save yourself a few steps, right? So if I have my slope, and then this right here tells me that my b value is equal to 1, because that's the y-intercept, I can go straight to y equals mx plus b, right? I have my m, and I have my b. Say y equals 2x plus 1, right? Same answer we got using point slope. Right? So either way, right, we got the same answer. It doesn't matter which way you do it, okay? But look for those little things that could save you a couple of steps. Right? Questions? All right. So special equations of lines. Okay, here we're talking about horizontal and vertical lines. So here we're saying we're going to draw a horizontal and vertical line through the point HK. Okay, so where H is just some x value and K is just some y value, right? So we've got this coordinate point right here. So I'm going to draw a vertical line and a horizontal line through that point. Horizontal lines always have the exact setup. At every single point, horizontal lines have the same y value. Therefore, the equation is y equals whatever that y value is. Okay, so here, if we're using this generic point HK, the equation would be y equals k, whatever that y value is, all the way across. Vertical lines then always have the same x value. So the equation of any vertical line is x equals whatever that x value is. In this case, we'll say it's h. Okay. So, if we want to graph these lines, what does the line x equals -3 look like? X equals -3 would be a vertical line at -3, right? And if you don't remember that, if you don't remember which is horizontal, which is vertical, just start plotting some points, right? This means that every x coordinate is -3. So just start plotting points that have an x coordinate of -3. And you'll see very quickly that that creates a vertical line, right? -3, 0, -3, 1, -3, 2, -3, 3. Right? How about a horizontal line through the point 5, 4? What does that look like? What does a horizontal line through the point 5, 4 look like? 2, 3, 5. So a horizontal line through this point 5, 4. What is the equation of that line going to be? What is it? Y equals 4. Right? Y equals whatever that y coordinate is. Right? Questions on horizontal and vertical lines? Right, so remember, horizontal line is a slope of 0, vertical line is an undefined slope. All right, last thing, parallel and perpendicular. If two lines are parallel, what's the relationship between their slopes? They are the same. Right? Parallel lines, their slopes are equal or the same. Right? What about perpendicular lines? What's the relationship between perpendicular slopes? One's positive, one's negative. That's half of it. And they're reciprocals, right? They are opposite reciprocals of each other, meaning one's positive, one's negative, and you flip them. Right? So they are opposites reciprocals. Right? I don't know what to put in that or spot. Well, they're different in a very specific way. Another way to say opposite reciprocals is that they multiply to -1. Okay? Opposite reciprocals will always multiply to -1. Right? So, in this first example here, I've got y equals 3x plus 1 and y equals -1/3 x plus 7. What are the slopes of these two lines? Yeah, right? So because we have this slope is 3, this slope is -1/3. Right? One's positive, one's negative, and they are reciprocals of each other. So these two lines would be perpendicular. How about in the second one?
Excuse the interruption. Staff and students, in a few minutes we are going to conduct a fire drill. Staff, please review the fire evacuation plans with your students. Thank you.
We're going to go down the front steps and out the main door. All right. So how do I get the slopes for these? Yeah. So here, I want to get y by itself, right? To put it in slope-intercept form, I'm going to subtract the x over. So 5y equals -x minus 15. And then divide both sides by 5. So y equals -1/5 x minus 3. So I've got positive 1/5 for this slope and -1/5 for this slope. Are those parallel, perpendicular, or neither? Neither, right? They are opposite, but they are not reciprocals. So this would be neither. All right. Actually, I want to do one more example here. We've got 2 minutes. Let's take this line here. 5y plus x equals -15. And I want to write the equation of a line that is perpendicular to this line. That passes through the point, I don't know, -1, 3. How would I do that? How would I write the equation of a line that's perpendicular to this, that passes through -1, 3? Yeah, so to get the slope of my new line, I want to take the opposite reciprocal of this slope. Okay? We know that this slope is -1/5. So if I want a line that's perpendicular to that, my new will be +5. Okay. Now we've got a point, -1, 3. I can write in point slope, okay, the equation of this line. So I'm going to say y minus y1 would be 3. So y minus 3 equals 5 times x minus -1. I'll just go ahead and write as plus, and then we're just solving for y. Okay? So distribute my 5. Y minus 3 equals 5x plus 5. Add the 3 over. Y equals 5x plus 8. Okay. We could do a similar thing with parallel. Right? If I instead said write the equation of a line parallel to this one that goes through the point -1, 3. Well, if I'm doing parallel, I would just use the same slope. Right? I would choose -1/5 to be my slope. Plug this point into point slope.